Hi, this is Team 7, and here is our result from homework 3. And we use these three banana and fast view respectively to implement the data visualization part. And in the following, we will answer the 4 challenging scientific questions as we show the results. And for the first question, what time-based trends exist for discussion of oil, iron, and other natural resources in the Arctic region? We will use first we will use banana to try to answer that question. So here is our banana panels. We will illustrate what the panel means later, but right now let's focus on the question here. All right. We can search oil here. And there are 900 results, and for those two charts here that will demonstrate what the data location distribution like. We can see from the chart here that most of the OU data are concentrated on the Arctic part and also Alaska, which is another OU concentrated parts. And then we will try to answer the ice part. We will search sea ice. There's more data returned since all the data that we got are from polar data, and we can see that also the ice data are more like in the Arctic region here. And here is also a tag cloud that we generated, and we can see the ice and data and glaciers here are the most important words here during our search. Now let's use fast view to answer the time-based part. So here is our fast view, and we search oil, and you can see here is the date data type that we generated from the solar part, and we can see here the data from 2002 are 6, and the data from 2014 are already 32. That may implies a data increment here. Okay, now let's go to the question number 2. How many regions of interest are represented by the data that you collected? Identify geographic regions. Okay, we will use a gadget. Oh, here are also 2 gadgets that we use to answer the question from the question 1. Basically, it's the same as we used in banana, but we implemented in the D3. Also use the solar server API and gather JSON from the solar part and implement this. Okay, now for question 2. So here is the cluster data that we generated from solar indexed data. And basically we can see the several geographic regions that we used based on the latitude and longitude that we generated from the data. We clustered all the data into several different parts, and for those parts here that are the see, the France is part of Europe and Norway, and those parts here is the document names that we have. So that may imply a geographic region that may be our interest. Okay, now let's go to question 3. Can you predict areas in which there are national security interests? For this question is relatively hard for us since there is no certain answer for that. We will try to answer it by using the data maps, try to find the relationship between the data distribution and the areas to uh, answer that. So here is the data map. This one is not from D3 gallery. This is another library called data map that is based on D3, and we use it to implement our function. All those points are the latitude and longitude information that we have from solar from solar. And as you can see here, each point represents area, and we can see that in the Great Europe region and in the North American region there are more data than other regions. We think that maybe there are more data, then there will be a higher possibility that the data there maybe contribute something to the question here. Maybe if there are more data, then the national security interest may play a maybe more important than other areas where there are no data at all. Okay, now also for question 3, we can identify the regions by the maritime, air, and sea. So here is the cluster that we generated, and basically in those clusters that are all the geospatial data that we use the Solar API to query and use parse the JSON file, and we put it in the cluster here based on the geolocations. Okay, now for the first one, is there a trend with respect to science data and measurements related to climate change? Is that time-based or geographic-based? Okay, now let's first use banana to search the climate change keyword. We can see here there are more than 30,000 results come back, and based on our chart, I think it's more geographic region based, because see here there are two parts that contains most of the data, which is Arctic and Earth. We can ignore Earth since we keep it since it's a geographic region, but it basically means the whole Earth. So here the Arctic part may imply more climate change here, and also the Colorado, Alaska, and border and United States may have more climate change data that may also imply that there will be more climate change here. And also there is, let me explain all our other panels. So for this panel here that is about the alders, so we extracted alder data from all the raw data that we crowded. See here, we have those alders that basically this chart means that which alder contributes more data to the datasets. Here is the average Aberdeen, I think, and Robert and Van and Falkingham, those people may contribute more data to the data sets that we crowded. And also, we would like to find the keyword and the relation between the keyword and location. So here is a heat map that demonstrates this relationship between keyword and location. And as we can see that ice and Arctic are more related since there are more ice in the Arctic, that's of course. And also, we can see the ice set is also related to Arctic, and the glasses and land and all the other keywords here. Also, we analyze the content types that from our data. As you can see here, the most of our data are HTML and XMLs, which are more common data formats here. Also, the between keyword and description, the relationship here. Okay, now let's go back to the main panel. Also, there is another chart that we implement based on these three. Here is also the other data that maybe is almost the same as the chart that I explained earlier in the banana. It's also those are also other names, and these are the amount that this author contributed to the data set. And those are all the orders that we can identify from the data. Okay, basically that's all we had, and here is the team information here if you want to contact us, and thank you for watching.